So for number 7, if we try to factor that denominator, that trinomial can't be factored. And it still has an x squared. So this actually changes how we have to do this. So this can't be factored. And it still has an x squared on the inside of the parentheses. So what this is called is this is a irreducible quadratic. So the form is going to be a little bit different. So the x is still going to just be a over x, but the irreducible quadratic is going to have not just one variable, but actually a bx plus c. So we need to take an x that's 1 power less than the power of the denominator, so that would be, because it's an x squared, it's an x. So you need b times x plus c. So then the rest of it is pretty much the same. I want to multiply both sides of the equation by x times x squared plus 3x plus 3. So that's going to leave me with x squared minus 11x minus 18 is equal to a times x squared plus 3x plus 3 plus bx plus c, I'm going to put that in parentheses, times x. So then when we distribute, this is going to be ax squared plus 3ax plus 3a plus bx squared plus cx. My next step is I want to group the x squared terms and the x terms. So I want to rearrange these. So again, why we rearrange them is because now we can factor. So I'm going to factor an x squared out of that first one, leaving me with an a plus b. Then factor in x, this will be 3a plus c. Then 3a. So I do that because now I can equate my coefficients. So I have an a plus b being multiplied by x squared on the right, and I have a 1 being multiplied by x squared on the left. So my x squared equation is a plus b is equal to 1. With my x equation, I have 3a plus c being multiplied by x on the right, and I have a negative 11 being multiplied by x on the left. And then lastly, I have a 3a and a negative 18. So my constant is going to be 3a is equal to negative 18. So if you type this into a matrix, and then if you do the RREF, you get negative 6, 7, and 7, which means my final answer is going to be negative 6 over x plus 7x plus 7 over that quadratic. And that would be your final answer.